When I was putting this presentation together, I was just having a little look around, and I come across this on Twitter from Brian Cox. And it was just a little message from Brian Cox in regards to the conference. And he says, perhaps they could put this quote below: everyone attending this conference is a shitbox. So that's what Brian Cox thinks of flat earth conferences. It was just a little bit of fun, like, to try and break the ice.
There is absolutely no basis at all for thinking the world is flat. Nobody in human history, as far as I know, has thought the world was flat.
The problem is, every single ancient civilization in history believed or knew the earth was flat. Yeah, where you can look at the Norse, the Hebrews, the Mayans, the Incas,
the Native Americans.
Yeah, the Navajo. You name it. Every single ancient cosmology depicts a flat earth. Yeah, I mean, does the Egyptian cosmology look like a spinning ball in outer space? I don't think so. You know what I mean? You've got the flat earth at the bottom. You've got the firmament above it with the stars, and they have got Nut, who actually swallows the sun and spits it out the other end, and the moon. So, as you can see, all ancient civilizations depicted a flat earth, and one of the questions what gets asked whenever you see somebody on TV and they go, "Hey, Bill Nye, is the Earth flat or round?" And they say something, and he goes, "It's round." And he says, "Back in ancient Greece, in Alexandria, when the sun was in a certain position and the light shone down a well, hundreds of miles away at Siam, there was a stick in the mud, and it actually measured the Earth." And that's how we measured the Earth, which is absolutely a load of nonsense. You know what I mean? Yeah. What did they use to pass the information from one point to the next? Carrier pigeons. You know what I mean? It's 2018, and when you ask a reputable scientist, yeah, proof of Earth's curvature or proof that we live on a globe, they refer back to ancient Greece. You know what I mean? It's 2018 now. For me, landing on the moon in 1969. What we should have in this day and age now is a 4K camera on the moon, fixed, looking at the Earth, rotating orbit. Yeah. But we don't have none of that. You know what I mean? It's nonsense. And I don't know if you've, I've said this quote a few times. This is a famous quote from Nikola Tesla, where he says, "Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation until they build a structure which has no relation to reality." What he's saying there is basically everything we get from scientists today is theory. There is no observations. Now, the only people I know today making real observations are flat earthers. Yeah, you know what I mean? You've got people like Ranty, who's always at the seashore making observations, shooting lighthouses from distances what shouldn't be there. You know what I mean? There's hundreds of people we could probably name, but there is only like flat earthers making observations. And one of the main tools for the flat earther is this beast, the Nikon Coolpix P1000, aka the Curve Buster, I call it. My friend Jenna Fredo lives in Buffalo, New York, and on a regular basis, she goes to Lake Ontario and she shoots the Toronto skyline from 30 miles away. So I'm just going to play a little video clip now. There's no sound to this video, but what you'll see here, yeah, she's used the Mick West Metabunk calculator, which measures the alleged Earth curvature. Now, at a distance of 30 miles, you're looking at 516 feet of hidden curvature. That's based on a ball 24,901 miles in circumference. Now, also, what you have to take into consideration, what Mick West did, you see, because flat earthers were beating the old Earth calculator, he created this new Earth calculator, which actually calculates the standard refraction into it. Yeah, so it makes it harder, yeah, to disprove the globe model with his calculator. But Jennifero's observation actually beats Mick West's Metabunk calculator. So I'll just play it here, and as you can see, she's at the seashore. So this is 30 miles away from the Toronto skyline. What you'll see in the right-hand corner now are overlays. All I'm doing there is just showing that the temperatures are all within 4 degrees of each other from both locations. You see that little white building there, the Rogers Centre?
Mm-hmm.
That little white building there?
Yeah.
That should not be visible whatsoever. Yeah, but as you can see, on a clear day, you can't see it every day due to weather conditions. You know what I mean? There's ever-changing atmospheric conditions. But on a clear day, what you can see is that Rogers building. And just here, I'll just read this out. So the Toronto skyline at 30.84 miles away from Fort Niagara, New York, the Rogers Centre Dome is only 282 feet high. Lake Ontario is 243 feet. The base elevation of the Rogers Centre is 267 feet, making the total height of the Rogers Centre 306 feet above the lake. Jenna's elevation was approximately 6 feet, and that is being conservative because I'm sure Jenna's not her eyeballs don't stand at 6 feet tall, so you're probably talking 5'4" where the eyeballs sit, you know what I mean, or the actual observation point. So she's being quite conservative with 6 feet. So she's 6 feet above the lake. Alleged curvature should have been 516.85 feet of drop, according to that Mick West calculator. The Rogers Centre should not have been visible. And just like I said with them overlays, the temperature of Toronto, Fort Niagara, and Lake Ontario were all within 5 degrees of each other, and the humidity was quite, well, it's really low, you know what I mean? It's at 43%. Now, if you went there on another day and the humidity was 65%, are you going to see the Rogers Centre? No, you're not. You probably won't even see the Toronto skyline on certain days. Yeah. So the question is, like, there's only one reason why we would be able to see that from that distance, and that's if there's no measurable curvature. But what mainstream will tell you, I'm sure you've seen the Joshua Nowicki image of the Toronto skyline from, I think it was 46 miles away, and when Fox News got hold of that, they says what you're seeing here is a superior mirage. Yeah. Now I beg to differ. Because if you look at this image here, what you'll see is, you see that bottle, you can see the red juice in it. Now, you can see the actual juice there. What you'll see is the light refraction actually bends the image down. So what you're actually seeing is an inferior mirage. Yeah, they're telling us that that object is magically rising up from behind the curvature. I'm saying the refraction is mirroring that image down. So if you look at the next image,
it's probably the complete opposite of what they say.
Exactly.
Anyway.
Now, well, like I say, if you look at this image, this is shot on a flat surface from a distance, and when you zoom in, what you do, you get that light refraction bending the image down, and you'll notice the reflection bending down. You see, you can actually see it mirrored downwards. Yeah. So what we're saying is that when we're observing skylines or whatever lighthouses from a distance, yeah, we are seeing the light being bent down and not magically rising up from behind the curve. So I think that's a good observation, and I think Jenna did a cracking job by showing that the image is actually being mirrored downwards and not rising up. Does that make sense?
Yeah. Yeah.
And here's a good example of that. Lake Pontchartrain, where you see the I don't know if some kind of telephone towers, but if you look at it, what it does, it looks like it's curving over the actual ocean. Now, what I've just showed there above is that mirror effect where the actual image is being mirrored downwards. I mean, if that was reality, yeah, we'd have to live on a kitchen roll holder. So, but moving on, one thing that's always apparent is the horizon, which is always at your eye level. Yeah. So whether you're at Lake Pontchartrain looking out across there, or whether you're on the beach, there's my foot there where I'm lying on the beach in Fuerteventura. Yeah. Horizon is at eye level. You go to Mount Everest, the horizon is still at your eye level, or you go up to 120,000 feet. And again, the horizon or the horizontal eye zone is still at eye level. Now, on a ball, yeah, that shouldn't happen because it should actually roll away from you. But what you'll see is the horizon is always at eye level. And what I did, I actually went a step further than that. And I looked into the GoPro Awards where the SL10 amateur rocket was sent up to, I do believe, 396,000 feet. Yeah. Now that is like a world record for an amateur rocket. And what you'll see, even though it used a GoPro lens, yeah, when you get that horizon equidistance, you'll see it's perfectly straight. Only when the camera is bent downwards that you will get like a convex horizon. And when the camera is faced the opposite direction, you'll get a concave horizon. But like I say, when it's equidistance, it's a perfectly straight line. What you have to take into consideration for as well is that image is shot with a 180 degrees cam. That camera can see 180 degrees. So there's a lot of horizon there. You know what I mean? And all I did there was I took that line tool there up there, and I just put it from that point to that point, and it makes a perfect straight line. The only time we see curvature is when we see things like the Red Bull space jump with Felix Baumgartner. Yeah, as you can see there in the background, you've got a nice big curved earth on the top. Remember, it says when the camera is face down, you get that convex image. Notice the horizon line is not at eye level now; it's gone past your eye level. Only when it's at eye level and equidistant do you get your perfectly straight line on the horizon.
And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. Right. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space, look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
And that's from Neil deGrasse Tyson's own mouth. So whenever you're up against a globularis and they say, I've seen the curvature of the Earth from an airplane window. No, you haven't. You know what I mean? If you go up to nearly 400,000 feet, you still can't see no Earth curvature. So where does Earth start curving? You know what I mean? 400,000 feet is 70 miles up. Yeah, it's a long way up. So on this here, this is from my old presentation, but I thought it's a good talking point because when you Google images of Earth from space, this is what you get. NASA will actually admit that they're cartoons, but they'll call them composite images. You know what I mean? And I'm sure a majority of people know this guy is Rob Simon, aka Mr. Blue Marble. Yeah, he's the guy who creates the Earth for NASA, and I think it's Blue Marble 2.0. He created it, and he's actually been quoted in saying he takes a flat map basically and he wraps it around a ball. That's all it does. You know what I mean? So there is no images of Earth as such. The only image they claim is a photo is the one from the Apollo missions. But if you've seen Bart Sibrel's A Funny Thing Happened on the Way to the Moon, and you'll see that the footage what he actually requested by the Freedom of Information Act, they sent him a tape, what they shouldn't have sent him, where it shows you Buzz Aldrin and Neil Armstrong faking the Earth from space, where they basically use the actual round window on the craft in low Earth orbit, or even lower than low Earth orbit. And what they do, they pull the camera back and put a little cutout on the actual window to make it look like the Terminator line and look like the Earth, what they're viewing the Earth from a distance.
It is photoshopped, but it's has to be.
What are we told? So we're told that we live on a globe and we're orbited by a single satellite, which we all know is the moon. Now, I'm not going to go into a lot of detail on this. Before, I went into a lot of detail about phases and stuff like that. But all I was interested in for this was what you call the lunar anomaly. Now, I'm going to explain that because there is a bit of confusion about the anomaly, because people say, hold on a minute, you're talking about the actual moon being at a distance. Now, if you look at this little moon here, where it's actually at its furthest point, and then it goes to its closest point, yeah, that is the lunar anomaly. Yeah. People say, well, doesn't that prove orbital mechanics in regards to Kepler's law of planetary motion? Because that's how an ellipse works, you see, an elliptical orbit. You know what I mean? It's the moon will travel around the Earth in an elliptical orbit, and there will be a closest point and a furthest point. Now, the fact of the matter is, yeah, the lunar anomaly was discovered in 2nd century BC by Hipparchus, who I mentioned before. He discovered the anomaly back then. So they knew over 2,200 whatever years ago, 2,500 years ago, yeah, that the moon, there was an eccentricity to the moon cycle. So there is a furthest point and there is a closest point. Now, when you look at the moon in the sky, yeah, the only time the moon looks bigger is when it's on the horizon, when it's rising and setting. Yeah. So what I set out to do, I set out to test all the cycles related to the moon. Yeah, and there is a lot. So what I concentrated on in this presentation, because it was leading up to the lunar eclipse, what I'm going to look at in a minute, was this anomaly, what they call the anomaly. So basically, when the moon's at its furthest point, they call it apogee, and when it's at its closest point, they call it perigee. But just before we do go into that, I just wanted to put the record straight on a few things, because there's a lot of myths in regard to the moon. Yeah. So you've got a lot of people say, oh, I've seen stars through the moon. Yeah, people say you can see blue sky through the moon. Why is the moon red? There's a lot of questions. Yeah. So what I've done a little bit of research into this. Yeah. Some people will still say they've seen stars through the moon. Every single person I know, yeah, Ali Madge, Jenna Fredo, Ron Hagberg, myself, we're observing the moon on a regular basis. Yeah, I'm talking, you know what I mean? In 2017, I was out in the garden at least 5 nights a week observing the moon. And I have never, ever, ever seen a star through the moon. I've seen a star go behind the moon. I've actually filmed Aldebaran go behind the moon, and it doesn't come out until it passes the old disk of the moon. So even if it was an half moon, it wouldn't pop out in the Terminator shadow part. It won't pop out until it's cleared that. Yeah, the old disk of the moon is there. And I'll show you in a minute, because if you do a long exposure shot of the moon, on a crescent moon, what you'll do, you'll light it up, yeah, and you'll see all the actual moon itself. You know what I mean? I'm sure you've seen like a little bit of a lit side, and then they light the other side up. In fact, I've got a photograph of it coming up in the presentation in a minute, so you'll get to see that. So, hello, Mr. Blue Sky. Yeah, there's a lot of people say they've seen stars through the moon, and they've also say they can see blue sky through the moon. Well, yes, you can see blue sky through the moon, which on this image you can clearly see it, but in reality you can't see blue sky from the moon. Yeah, because you need to understand how light works. Now, the light spectrum, you get shortwave light, which is the ultraviolet scale of the light, and you get long wave, which is the infrared scale. Now, what happens on the ultraviolet scale is the light scatters easily, and that's what creates the blue sky. When light scatters, the shortwave light, what it'll do, it'll scatter and it will turn the sky blue. So in reality, for an analogy, if you want to think about the light spectrum, think about the sound spectrum. When I make a high-pitched noise, yeah, what'll happen? Your ears will vibrate quicker, yeah, which creates a high-pitched, which you hear a high-pitched sound. If I make a low rumble, your ears will vibrate slower, and you'll obviously hear a low rumble sound because the eardrums are vibrating slower. Now, there's sounds at either end of the scale. So there's sounds we don't hear, like high frequency sounds, and then there's like sounds at the other end of the scale, which is low frequency sound. Alligators make a certain sound which can't be detected by the ear, and bats make a high frequency pitch noise which can't be detected either. So think of light like the sound spectrum. You know what I mean? Where the light waves will scatter easily, and when they scatter, they turn blue. Yeah, and the ones what will penetrate through thick, denser atmosphere is the infrared scale. So that's why on this next image, what you'll see is, notice these mountains from a distance, what I filmed in Fuerteventura, they're translucent. But do you really think if an object went behind the mountains, you'd see it? The answer is no. Yeah, them mountains are solid, but because the light is scattering due to Rayleigh scattering, it causes an optical illusion, and it looks like the mountains are actually see-through. But in reality, you get closer and closer to the mountains, the solid rock. Now, I'm not saying the moon's solid rock, but you get the same effect with the moon, yeah, where the light gets scattered, and you can't see, and you can see blue sky through the moon. My good friend Jenniferado shot this picture of the moon here, and as you can see, it's a half moon. And if you look carefully, if you edit that picture slightly, what you'll see the whole moon. Yeah, the whole moon is actually there. Although it looks like you're looking at a half moon, in reality, the whole disk of the moon is always there. If you get the right exposure, yeah, you will be able to light that other half of the moon up. It's just getting the right exposure. You know what I mean? It's difficult. Like I say, it does look like the moon's not there, but in reality, it's always there. There you go. There's a good example. Yeah. You've got a crescent moon, but what I've done, I've overexposed it and I've lit up the dark side. See, normally you would only see the crescent moon in the sky. But what I did, I actually lit up the dark side by overexposing the moon, or doing a longer exposure of the moon, and it actually lights up the whole moon. So that's just to give you an idea that the whole disk of the moon is always there, and no, you can't see blue sky through the moon. And some will say they've seen stars through the moon. Every person I know has been observing the moon has never seen it. Just going on to the red moon. So one of the questions that I've been asked me, well, why is the moon red? Well, this is simply at the other end of that light spectrum, where you've got the short wave, what scatters. So what happens then is the longer waves of light, which are on the infrared scale, will penetrate the dense atmosphere, because as the moon sets, it will be setting against obviously a denser atmosphere. You know what I mean? The lower we are, the denser the atmosphere, and as you can see, that all that white light has been can't penetrate through that dense atmosphere to the observer, and what we see then is we just see the red come through. So that's why the moon is red. And there is a few questions asked about why does the total lunar eclipse moon turn red? Because in reality, it's being blocked, yeah, by something, or something's, you know what I mean? In the globe model, they're saying it's the Earth what's blocking it, but there is definitely something either going in front of that moon or going behind it. That is without a doubt, because the only reason why that moon would turn red is if something is blocking that light, blocking that white light from coming through. And just a quick look there at the actual the light scale. So you've got your ultraviolet at this end of the scale, and you've got your infrared at that scale, and you've got all your colours: red, orange, yellow, green. I've always liked this quote from Tesla. If you want to find the secrets of the universe, then think in terms of energy, frequency, and vibration. So, as I mentioned before about the moon, what we are told, yeah. So I wanted to test the what you call the lunar anomaly or the anomalistic cycle. Yeah. So what I did, I set out to test it. So like all my observations, what I use a compass and a compass app. I use Dioptra on Android, but you can use Theodolite on iOS. What I've done here, I've just opened up the app. It gives you an azimuth, a declination angle. It gives you a location and time. It gives you all the information that you need. You've got your tilt. Yeah. So all I did here was place it over the compass to see if it was accurate. Yeah, because if I'm going to be making readings with a phone app, I still need it to be pretty accurate. You know what I mean? So as you can see there, I laid it over there, and it's pretty accurate. Yeah, the compass pointing north, and it's at -0. I don't know how to get -0, but it is pretty accurate, like I say, and I'll show that in a minute when I go through my observations. On my first observation on the 23rd of August this year, the moon was at apogee. So what I did, like I always do with all my observations, I always make my observations when the moon is at my zenith. Now, zenith is when the moon is at its closest point. So between rising and setting, it's that point smack bang in the middle. Now, my zenith and everybody's zenith in the northern hemisphere will always be 180 degrees south for every observer. So everybody in the northern hemisphere, their zenith point will be 180 degrees, and everybody in the southern hemisphere, theirs will be 0 facing north. Yeah. So what I did on the night of the 23rd of August, I took a diopter reading. Yeah, as you can see, I always catch the moon at 180 degrees. That's to try and keep my observations consistent. Because, like I say, if you're going to measure the moon, if you measured it when it's rising, then at apogee, then you measured it when it was at zenith, when it was at perigee, you're not going to get a consistency. So if I do it at 180 degrees south, which is my zenith, the moon's closest spot, I'm going to get a more accurate reading. So as you can see there, on that night, the moon was at south. It was 182 degrees, and it was quite low on the horizon. It was only I think it's about 9 degrees. There was a little bit of a discrepancy between my reading and Mooncalc's reading, which I'll show you in a minute, but I think there's about 3 degrees in it. So as you can see there, I don't know if you can see that there, but according to Mooncalc, yeah, the moon direction was 179 degrees, and the altitude was 16 according to theirs. So I was like 70 degrees out. But yeah, I've mentioned this before. If you don't calibrate the app properly, yeah, or you stand near something metal, yeah, you will actually get a bit of a off reading. All I'm doing now is just making sure that the observations I'm making and match up. And yes, I am using mainstream, but as you can see, it's only for the direction and the actual angle of the moon. What I do then, I just compare it with what NASA's telling us. So NASA are telling us that yes, the moon is at apogee, and as you can see, we're in the exact same phase there. So the moon is at apogee then. So what I did then, I used a measuring tool to actually measure the moon in pixels. So as you can see there, I don't know if you can see that with on your screen, but the moon measured 227.56 pixels. Yeah, so just keep that in mind, because that was the first reading when the moon was at apogee, and apogee is the moon's furthest point. So then on the 27th of October, I waited till the moon was at its closest point at perigee, and I repeated the observations again. Same again, I waited till the moon was at my zenith, which is 180 degrees. It's just a fraction before there, but it's not too far off. So you can see now, when the moon's closer, it is actually high on the Tropic of Cancer at this point. that does change, and I'll go into that in a little bit. So if I compare that with Mooncalc, there you'll see the reading's 179.77 and an altitude of 53 degrees. So it's pretty close, that, you know what I mean? My observations are pretty close to what mainstream is telling us the direction of the moon. Again, just compare them phases at NASA. As you can see, it's the exact same phase. So just to keep in mind, when we measured the moon first time, it was 227 pixels. So when we measure it perigee, guess what? It's 248 pixels. So it's grown significantly. And if you put them side by side, you can just about see with the naked eye that the moon on the right is slightly bigger. So there is actually a point where the moon is closer and does appear bigger, and when it's further away and it does appear smaller. Now, what I did forget to mention is I'm using the exact same focal point on the camera. So I've got the Nikon Coolpix B700, which has got a 60 times zoom. So the maximum focal point on that for optical is 1440 millimeter, equivalent to a 35 millimeter camera. Yeah, so I always make the same observations at the same focal length, which is 1440 millimeter. The P900 shoots at 2000 millimeter, so I'm sure people who've got that, they know it. When you're on the moon setting and you click the 2000 millimeter and it goes to its optical zoom there. So what I've shown here is that there is an anomaly and it can be measured, but like all observations, you know what I mean, I like to repeat it to make sure it's not a one-off, because you never know, do you? So what I did again, I set out in September, this time when the moon was at apogee on the 20th of September. Go through the exact same process again, same focal length on the camera. The moon is at my zenith, 180 degrees. Compare that with what mainstream's telling us. You can see again, the moon is at apogee. One thing I did forget to mention, I actually made this observation when I was in Fuerteventura. Yeah, that's not the UK there, by the way. That's actually Fuerteventura. So actually, I took the opportunity to actually shoot the moon at apogee when I was in a different country. You know what I mean? To see if I got some different results, which is always good to do. You know what I mean? To have from different locations.
Yeah, you were telling us before that you use apps anyway because all the information is coming from a flat plane, and that's what they're using in the first place.
Exactly. So, as you can see again, according to NASA's globe model, the moon is at apogee again, so it's at its furthest point. So when I measured the moon again, as you can see, 228 pixels. So it's actually smaller again. So every observation I'm making is actually matching up. You know what I mean? So there is an anomaly, whether we like it or not. Yeah. And then again, my last observation, which was only like 2 weeks back on the 25th of November. Yeah, the moon was at perigee, at its closest point. So I took the opportunity to capture the moon again, just to complete the 4-part observation. And there you can see 180 degrees, my zenith, high in the sky again at 56.7 degrees. So it's quite high in the sky. Again, what I'm doing, I'm checking with Mooncalc to see if my observations are accurate, because it'd be a bit daft if I got a reading of 180 degrees and I looked on Mooncalc and it said it was 270 degrees west, then there would be questions asked. So let's look on NASA's model. As you can see, the moon is at its closest point at perigee now. And if you look at the measurement there, it's now 250 pixels. So there is a significant change in size. So on the left, you've got the moon at apogee, and on the right, you've got the moon at perigee. So there is quite a big difference. And what I've got here, I've just got a little animation just to show you them differences. So there you can see the moon at apogee, There you'll see the change in size at perigee, slightly bigger. Then again at apogee, the one from Fuerteventura. So even when you're actually getting closer to the moon, it's still appearing smaller. So, and there's the last one I recorded in November. And just to keep in mind, all them were shot using the Nikon Coolpix B700 at the exact same focal length, which is 14 millimeters, which is equivalent in 35 millimeters. You're probably wondering why I measured all that, don't you? Because what I'm doing, I'm testing all the cycles related to the moon. Yeah. Now the first one on my list was the anomalistic cycle, which is 27.554 days, yeah, to complete a cycle. I've mentioned the moon cycle before, yeah, because there is quite a lot of cycles, and this is not even half of them. There's a lot more cycles related to the moon, and to try and get your head around them all is very, very mind-boggling. So the anomalistic cycle takes 27.55 days to complete a cycle. The sidereal, yeah, which is the point it takes the moon to pass through all the constellations and get back to the same point again, is 27.3 days. The tropical cycle is a point it takes the moon to get from one point on the celestial equator to pass through to the Tropic of Capricorn, back to the Tropic of Cancer, and get back to that same point on the equator again. That's 27.32 days. Then you've got the draconic cycle. Now, this is also known as a nautical cycle, which is basically related to eclipses. When you get a lunar and solar eclipses, there are points within that cycle, yeah, called nodes, which are actually where the moon will line up to be eclipsed. And basically, the draconic cycle is the point it takes to get from one node and back to that same node again, and that cycle is 27.2 days. And the last one, which is on this one, is a synodic cycle, which is actually the phases. So the time it takes the moon to go from new moon to new moon takes 29.5 days. Now, trying to get your head around just them few cycles, if you're trying to think about the moon, you know what I mean, it's quite mind-boggling. But interestingly, the anomalistic cycle is the perfect clock. Plus, I think I'm going to need my calculator for this. Let me just get my calculator up so I can work it out. The average days per year is 365.24. Yeah. If you times that by 4, which is included the leap year, you get 1,460 days. Yeah. So just keep that number in your mind, 1,460 days. Now, if you take the anomalistic cycle, which is 27.55 days, yeah. Now you get 13 of these in a year, yeah. So 2 years would be 26, 4 would be 52, but you have to count the leap year as well. So you'd have 53. So if you take 27.55 and you times that by 53, you get 1,460 days exactly. You get the exact same days, yeah. So the lunar anomalistic cycle is the perfect clock over 4 years. It fits in to the Gregorian calendar or the solar calendar, what we use today, yeah. But in reality, you could use the anomalistic cycle as the perfect clock, which is quite interesting. And so if you think about the dates of the points of apogee and perigee, they literally fall on the exact same day every 4 years. Yeah. So if it fell on the 20th of, say, on the 25th of November, yeah, in 4 years' time, guess what? The moon will be at perigee on the same day in 4 years' time. And what it does, it changes every 2 years. So every point at perigee, 2 years' time, switches around, and that point then becomes apogee. Yeah, they don't fall exactly on the same day, but they're close. But then you have to take into consideration them days at apogee then fall into that 4 year cycle as well, and it continues. So the best measuring tool for me, like if you wanted a really, really super accurate calendar, would be by measuring the anomalistic cycle.
Right.
It is quite a lot to get your head around that, and I hope you come across. I explained it quite clear. So basically, the lunar anomaly fits into the 4-year calendar exactly. Yeah, you got 1,460 days for 4 years, and same with the actual cycle when you times it by the amount. So now all this is leading up to one thing, because on the recent eclipse we had back in July, yeah, something really, really amazing. Well, I think something really amazing happened. Yeah, because what happened is we didn't only have the lunar eclipse. For a lunar eclipse to make, the draconic cycle has to be aligned. Now we know that a lunar eclipse only takes place on a full moon, so the synodic cycle had to be aligned as well with a full moon. The moon was also at the furthest point on the Tropic of Capricorn, so that tropical cycle aligned with the other cycles as well. Yeah, and not only that, yeah, the moon was at its furthest point in the anomalistic cycle apogee. So every single one of them cycles had to align up. Yeah, and what we got one of the longest eclipses in history. You know, I mean, in our history, I'm sure there'll be a lot longer ones previously and in the future. But one thing to keep in mind: the only time you're ever going to see a full 100% full moon is during a lunar eclipse. Now, what you'll see is the moon is completely 100% full. I'll give you an example. Yeah, this is a 99.9% moon. Now, you can see it's like it's 100% around that side, but as you start getting near the top, you can just start seeing it's not actually quite 100% full. So the only time you can actually observe a perfectly 100% moon is during a lunar eclipse. Now, on the night of that eclipse, something interesting happened, and when I looked at the actual numbers, I couldn't get my head around it, and I'm sure mainstream, I've got an answer for it, but I haven't found that answer yet. And believe me, I've been looking and I've been asking the question. So I call it a lunar standstill. So on the 27th of July, when the eclipse actually started, although the moon wasn't visible from my observation point there, yeah, if you look down here close at this full moon, it's at 100%. So that was at 3:45 in the afternoon. Now, almost 12 hours later, yeah, at 3:01 on the 28th of July, the moon is still at 100% full. Yeah. Now, for the moon, don't forget, MoonCalc uses a decimal point as well. So, you know what I mean? We're talking decimals here as well. So it's remained full, yeah, at 100.0% for 11 hours, 46 minutes. We have to take into consideration that the moon shifts 13 degrees a day. Now, how can that moon stay full at 100% when it's shifting 13 degrees every single day? It doesn't have days off for lunar eclipses, but I call it a lunar standstill, but that is impossible in the globe model. Yeah, when it's in constant motion, it would be impossible. So people say yes, but it's lined up 180 degrees perfectly. Even so, it's still moving 13 degrees a day, every day. You know what I mean? So to me, that's like a big hole in the heliocentric model. And luckily, in January, on January the 21st, we've got another total lunar eclipse. Same again. All them cycles will all be aligned again, but the only difference this time is, instead of the moon being at apogee, the moon's at perigee for this cycle. Yeah, to the exact day it's at perigee. Well, what is the moon? You know what I mean? Because there is a lot of questions being asked. What is the moon? You know what I mean? It's there just about every night, apart from a few nights every month. Yeah, but we still don't even know what it's there for or what it does. Sometimes the moon looks like a light. That's just like a slightly overexposed image of the moon. Sometimes the moon looks like a rock. You know what I mean? I'm sure when you get close into it, you think, "Wow, look at all them craters." You know what I mean? They just look like rocks or that. On the odd occasion, it even looks like a sphere. I mean, I've looked. This was I think this was the strawberry moon from 2016, and I thought to myself, it looks a bit spherical, that. But then when you look at another full moon, it doesn't look spherical. It looks more like a disc. You know what I mean? So the moon is so many things. Is it a projection that you can see an overexposed image of the moon? What it does, it creates a lens reflection and creates an image of the moon. That light has created that image. I know that a lot of people have actually even thought the moon's a hologram. Yeah, there you go, an overexposed moon again. What it does, creates a holographic image of the moon. So the moon, you know what I mean? It's a lot of things, and actually the word lunatic is derived from the word lunar. So which is quite interesting. I'm sure you've heard like how people how crime rate sometimes has been increased during a lunar eclipse, or people have reported feeling different. You know what I mean? There's a lot of things related to the moon. It's not just in the sky. There is something else. Yeah, there's something supernatural going on there, I believe. And even the word month is derived from the word moon. You know what I mean? So they're telling you then that the moon is a perfect calendar, really. And I really have to actually show you the actual figures on screen. I will do that eventually, but I haven't actually got around to doing that yet. But when I do, you'll understand the lunar anomaly is the perfect clock. Yeah. Or if we knew how to measure it like properly, we could actually use that as a perfect calendar, and you wouldn't even like I say, probably even need that leap year. So like I say, what is the moon? Yeah, we just don't know. It's been there for a millennia. We could observe it for another 1,000 years and still be none the wiser. But like I've said before, one thing I'm sure it's not, and it's not that. I've showed this before, but they claim this is a real photograph, and the moon just happened to be passing by Earth from the Discover Epic satellite, which is supposed to be 1 million miles out, which is absolute nonsense. And that's it.